open up this chapter 8, the string and vector, with more examples. So I prepared about 5 different programs tonight, and that I could display it for you and run it and show you and go through each one of them. And as of now on this, let me put this one on the side here. I believe I need more on the right side than on the left side, things that are there. Alrighty, so on this chapter 8, we went through C string and string modules of C++, and I put this examples with vector, dynamic list, or dynamic data structure. So I'm going to start off with example 1, but later on tonight I will post this one also along with the rest of the examples. So you will have on this module at least 4 more programs with their output and everything. But before I put it, I want to just demonstrate it to you. And then also the video that is available afterward, I'll post it here. So let me just go right here on the command lines, clear screen. So I already started Xming, which is my client to just set up an X terminal here, and I'm already on the program files. Let me just clear the screen. I'm going to type in uname -a. This is the Linux machine that I'm running. So the reason I'm showing that one is to show you that the programs that we're running is on a Linux platform, which is a x86 architecture. So let me just do a few commands to tell you how you know, for example, the machine type is x86, and then the platform is the same thing, x86 64-bit. And the version of the operating system basically is Linux. And if I do cat etc os-release, you can see that it is Linux Ubuntu and Linux Mint 19.3 version. So, and the version is 19.3. There's a 20 version, but I am not upgrading it yet. So this is the current version as of today, for me at least, December 6th, and this is the current stable version that I'm using. So December 6, 2021, and obviously I told you that Linux Mint 20 is there. I don't have to upgrade it at this time, but if I want to, I will upgrade it at a later date. So here I'm running the G++ dash version, and you can see that the G++ version is 7.5 Ubuntu, right? So this one was compiled with GCC 7.5 and G++. GCC is when you compile a C program, and G++ is when you compile a C++ program. So this is what it takes to compile it. If I want to see the processor, I told you that uname -m stands for the x86 machine type or architecture or platform. I could also look for cat proc, which is the proc file system, which is memory-based pseudo file system. I could say CPU info, and then say grep -i. In this case, I'm going to look for architecture. So if the architecture is not there, and then I could say CPU. If the CPU type is there, you could see that the CPU family and the CPU size and everything, megahertz. And then let's see if and this machine is AMD for advanced micro device. Yeah, it is model name. So I could have just searched for, instead of architecture either could search for model name or vendor or vendor ID. That would say the type of there. So yeah, you could say, like, for example, model name. If you just put exact word and this, you have to put, when it has a spaces, put it with double quotes, and then it will tell you that this is, yeah, x86 AMD processor. So that means that if I compile my codes, my C++ program, in this case, this list of my vec star.c++, if I just look at all these ones, these are my source code. You can see the permission of these ones are read write for the owner, and then the group, and then read for others, because they're source code. They're not executable. So before, if I look at the type of the file, my vec star.c++, they are all C++ source code. So on Linux, you can just know exactly what you're doing and how you're manipulating it, getting it. Yes, you can do the same thing with properties, and with Windows, you have some buttons to just do it much easier. But sometimes if the button is not provided and there's no command line options, or you don't know the syntax of it, it is kind of a little bit tedious to just do it within Windows, when the options is much easier if you're programming it in C++ or Python or Java or something. You can do a list of them in one shot. So that is easier in C++, I mean, on Linux or Unix, if you're doing batch type of checking on something, rather than just one file at a time. Because when it is a click of a button, for each file you have to click. But if you want to get a list of them in one shot, like here I did, file star.c++, and it shows there. So the first one that I'm going to demonstrate today is my vec1.c++. So let me just open up my vec1.c++ and vim, my vec1.c++. And actually, I need to just, before I do this one, I need to run my program called my extern.sh. I told you that I set up this extern.sh in order to clean up some good, in order to generate some nice extern session for me, because I ran the xming already. So I'm going to run this my extern.sh. It's going to open up all these 5 windows and extern, and each one of them is going to be a different color based on this foreground and background in the font that I wanted to use on this. So as of now, I have these 5 different windows. And the first window is this color, and the second one is, let's say, blue. And then the second one is this color. So I have different colors, right? I'm going to use, for the first program, this one. I look like this one is a nicer color for the first one. So let's just resize this one to the size we want, which is going to be more easier to read. And this side, I'm going to just move it to right here. And this other one, I minimize it, all of the background, so I could just have this one a little bit nicer when I format it. Right there is good. So I do this in this window. I'm going to do a host name again, pwd, and you can see my terminal set with X session. And the reason X session is working is because my display was there and then everything else. So I'm not going to go through that one again. If you are interested on knowing that one, I have an extern session that I have posted in our class, as well as on YouTube, and as well as MyWebUniversity.com website. So you can find that video and then just see how you set up your display. But here, I'm going to open up my vic1.c++. So this is the content of my vic1. If I just set my line number, set NU for line number. Now line 1 through 10, I have comments. And on that multi-line comments, I write the name of the program, the description for the purpose of the program, and then who wrote it. In this case, it's me. So the program, what it does is the description. It reads, it says that to read some integer values from the console input until the first negative number is entered. It store all of the values read into the vector, my vic1, then display the values that were provided as input. As simple as that. We're just using the IO stream and vector and IO manip libraries. The reason I'm using the IO stream because every cout, cn, inline, everything is defined in the IO stream, and also the name conflict resolution is using namespace for std. Since we're doing std here, namespace, if I'm just doing cout or cn, I don't need to put std : in front of every times I use cn or cout or inline. So the reason we're doing vector, because we're using the vector data structure. Vector is basically a dynamic array or dynamic list of elements that you can grow and shrink in size. So you resize a list that accept integer values. For example, you can have 10 elements originally or 0 elements, and you can just add to it. In opposed to array was a sequential list that allows contiguous elements into memory segments that is stored those values. But the problem is with arrays, once you size it with size of 5, you cannot grow it. If you want to grow it, you have to just declare another array. If you want to declare it with a size of 100 elements, then you cannot add the 101 elements. And that is going to be, array is going to have a buffer overflow. And then with vectors, you can resize it dynamically, you can shrink it, you can add to the elements by calling some member function of vector like pushback, push_back for inserting it, and popping it for using pop_back, and so on. I mean, there's insert, find, and a lot of the other arrays and add and this and that. So there's a lot of functions. We will not go over every one of them, but we will go over the majority of them. The fact that you can update a vector, whether you insert or delete or erase or something, we need to know that one, and I'm going to cover that. Even though on chapter 8 of your book, it is just what I showed you last week. One examples on vector, that is just how you just read the data into a vector array structure, because the rest of the information, it should be used maybe on chapter 9 once you understand pointers, and later on some other chapters like iterators and everything. You're going to do a lot of the vectorization kind of work on the computer that you work. A lot of programs that you write is dynamically in data structure. And vector is last in, first out kind of data structure, meaning that it is kind of like a stack. Whatever was last in put onto the stack, it is the first that comes out. That's why it's called LIFO, or last in, first out. In computer science, there's 2 data structure at least, and that are working on the stack and queues. So one is called the stack, which is last in, first out, like this vector is. And the last element that was pushed into the vector is going to pop up first. And it's almost like a shelf of books on top of each other. You pick up the last book, or a shelf of trays in a restaurant. What was last put on that tray shelves on top of each other, the last tray is going to be popped first. So that's what the last and first out is. There's another data structure called queue. Queue is like almost like a waiting list, whether it's a cashier list or a restaurant. People that are first in, they're gonna go out first. First in, first out. That order, like if you're in front of a cashier, the first person that you're in, you're going to get out first. That type of data structure are also used in programming languages, and we will discuss, maybe not in this class, all these data structure, but there's a data structure class, I believe CS03A or some number like that, but it's a data structure class, so you will be introduced to all different type of data structure, whether it's arrays, vectors, in Python they call it a list, tuples, and data dictionary, and C++ data dictionary is called map, and then you have a number of these sets, and then struct and C and C++, you have a struct as well as class. And with class, you have object-oriented programming that you could just do object stuff that we did a lot of different examples of it. But I believe chapter 10 of your book or 11 of your book also goes through the class. And you're welcome to ask a question if you're interested. At office hours, I'll explain to you what I know and what you should know for your classes. So here we're doing vector, declaring vector as, and there's two vectors. One is vector integer myVec1, and the second one is last vec1. So in this case, I declared the first one to just read the data, and the second one as a result of what I'm doing with some input of my vector1, I'm picking up certain elements and storing it, the last two or three elements of my vec1, and then store it to the last vec1 in the program I'll show you. So here I'm defining int last because whatever was the last element, when you pop it, it does not allow you to print it on a cout saying that what you popped and this was the last element. So in order to do it, you could just put it into an integer variable and then save it into an integer variable as a temporary and then print it after. But if you want to do it in a list of them, you could just put them in a vector called last vector. And so every pop that you do, you store it to this new vector called last vec. That's what I did here. So enter a list of positive number ending with a negative number. So whatever the user gave, I'm going to read it into numbers, or number in this case, int number. And then CN is going to read it. Notice that we're not doing any kind of C ignore or C clear or C dot fail or C dot good, making sure that the data that are entered are numbers, not double or not a string or not characters. So you can validate it. We went through a lot of those examples with data validation on chapter 4 and 3, I believe. And if you have question, I can stop and just show you how to do that. But at this time, we want to just learn vector. So to minimize the kind of like details, let's just cover what is important about vectors. So with vectors, when I say while a number is greater than 0, meaning that as long as the user does not provide any negative number, I'm going to put that one into my vector list. I read each element, and then once I see a -5, -1, minus anything that is greater than, less than 0, then the while statement is going to stop reading. But it's very, very important that on line 29, you have to have CN number. a CN number, meaning that this one basically you have to read it. Otherwise, if you're reading the number here, then you're doing this kind of sizing. My vec1 dot size will just keep growing into an infinite loop because you're not giving the number, reading the number. So it's very important on line 29, you're not missing that one on your program. Let me just move this one character here. Actually, right here is good, and then that way I could just have that end of line and match to this. And actually, I'm gonna do a couple of more lines, and this one too. So this one is all in one line now because we resized the window. I want to make sure that you see the other one in one clean line. So here we read the numbers, and then now you enter the following numbers. So we tell the user back what the numbers were done. In this case, we're doing also one of the SLO, student learning object, to talk about the memory content while we're working on. So for every elements we're doing is we're also displaying the address of the variables and the elements here. So this one is going to show the memory, and then we're using setW to set the width because we use the IOMANIP module. IOMANIP allows you a number of these formatting functions to just format your data to display it better, cleaner. So we're displaying memory address, element number, and element value for each one of them. And then now we're going to go for a for statement. The for statement, notice the for statement has unsigned, meaning that it is only accepting positive numbers, because we said only stop it with the minus negative number. Once you stop the input with giving a negative number, we're not reading on those numbers. So this for statement, it says for unsigned int, meaning that that's going to read all the positive numbers. Then I is my vec.size. My vec.size is growing. Every time if I don't have any elements, my vec.size is empty. Once I just add the first element here, then I'm not adding it here yet. But once I add the first element, my vec1 dot size would be like 1, and then 2, and so on. So here we're just saying that these were in the vector, reading from this to the end, making sure that they were inserted here. And then the elements are pushed here. So at this time, we say that elements were pushed onto the top of stack, last in, first out. Now we show the elements in the LIFO order, because every elements that are pushed into the stack are just basically inserted. And the way we insert it here is there's a statement here. Let me show you what I did here to say my vec sub I. And this is my vec sub I. And these are all just actually on the vector, because we're reading the content of the vector. When we did the push, we did at the time of reading, right here, push back. So at the time that was inserted, it was inserted here. Push underscore back, and then the number, each number as we go to the while statement is pushed into my vec1. So my vec1 will have the first element, the second one, the third one. As long as they provide some numbers, not negative number, we keep pushing it into my vec1. And then here, the my vec1 dot size already has the number of elements that the user has. So if we are writing it in the order that it was given, we use I less than my vec dot size I plus plus. If we are writing it in the reverse order, then we are going to do my vec I is equal my vec dot size. So we start from the end and then go to all the way to the first element and decrement it from end one number every time. And then that's how we display it. So, and then here, unsign my vec1 size -2. So here I'm popping 2 elements. You see, after popping the last 2 elements. So the way you pop, you just say, for example, here I'm just popping one character at a time, but one integer at a time. But every time I pop, I use my vec.back. This .back member function is pointing to the last thing that is on the stack. So you just use that one to store it into a value that later on you can just assign it to this other vec that I just vector last vector. So every time that I just pop it, before I pop it, I just do store it into a last integer, and from that last integer later on I just go by the size of my vec, however many that one grow, then I'm just going to push back to it, so that this pushback last will just put this one into last vec, and last vec now has the last 2 elements. And the reason I say last 2 elements here, because I say size and then my vec.size -2. If I want the last 3 elements, my vec.size -3. And if I want it to the beginning, from the last element to the beginning, then my vec.end. I mean dot begin rather than or -1 or something, depending on how many elements you want to insert. Be careful when you're doing it, anything that is behind the end or before the beginning, if it is not pointing to those ones, it will be just segmentation fault. You don't want to just do reach in the memory address space that does not belong to your vector. Same thing that we did with arrays. You just don't want to go buffer overflow or underflow. You don't want to do that. So this is the example of this. Let me see the timing. We have good time. So I'm going to stop showing you on example 1. I'm going to say WQ and I'm going to compile it now. So in order to compile it, as you all know, is G++ -O for output executable, my vec1.c++. I'm sorry, my vec1 is the executable, my vec1.c++. This is saying that generate and create an executable file called my vec1 binary executable file from this source code, my vec1.c++. This option of -O, in addition to compiles this program, it also links to the loaders with all the standard C++. So automatically you have a list of shared object files dynamically linked to this. So now if I type in file my vec1 star, you can see that the executable file is executable links 64-bit, and it's x64-bit architecture, and is dynamically linked. Dynamically linked because it's all this loader Linux LD. There's a file called LD. There's a file called AS for assembly, and there's a call file G++. So in this case, the G++ that we use, this one had the option of -O, that it uses this LD in addition to compile it with -C option of it, because in the underneath this -O, it does a -C as well as -O. And then it also uses this LD and also uses AS to create my vec.s for assembly code. So it uses this one, and then it uses to create an object file first, a .o file, and then from that O file, it uses this assembly to connect that .o file, and then also the LD file to finally create with this -o executable file that we just saw in this name. Okay, so at this time, if I just say LDD myVec1, sorry, I just had a typo. Okay, myVec1, you can see that LDD myVec1 is showing that all these dynamic link libraries .shared object, meaning that now if I'm using IO stream is just making some lib standard C calls or anything, cout, cn, all of those ones are defined within these libraries. And then the libc or libmath, this is libmath, this is libc, this is libgcc, and this is lib standard C++. When you're doing include libstdc in order to do some work on your system, these libraries automatically get added. This VDSO is a virtual dynamic shared object. So a lot of these things, when you do which LDD itself is a binary that finds out what or the shared object file for this one. So now we have the object shared files for it. We're going to just execute the program. Actually, we did a file on it, and you know that that is there, so I'm not going to do a file on it. If it says that enter a list of positive number ending with a negative number. Can anybody give me some number, or I need to enter it myself? Anybody?
13.
13. Next one?
15.
7.
15. 7. What else?
4.
4. Any other?
3.
3. And let's just stop there, and we are going to give a negative number. So who wants to give any negative numbers? Minus?
2.
2. Okay, so the negative number, when we say put a negative number, as long as when we say less than 0, as long as it's this number is negative, it's always this. So you are not tied to -1 as input. So now we're giving this input. Our program is going to do some work here. Okay, so let me see if I could just do this same thing. Let's go back with, unfortunately, I resized the window, and with extern, and you're tied with a little bit. So let me just go back on this other window. I'm going to just open up here and run the same program here, and we have these bars. We can move it up and down, so it's okay. I'm going to just run the same program here, and let's just clear the screen. And then we're on the same directory. That's my vec is all there. So I'm going to run my vec1 as input. So the inputs were 13, 7, 4, 3, and what other number were there? Any number, you just give me a number. One more. Or 2 more, as many numbers you want.
15.
15. And let's do -2 after that. So now you can see that this program, it says that these words were entered after adding 13. My vec had a size of 1. After adding, I could put a space after this 1 and compile it, and there should be a space there. My vec has it, but that's just a cout. We can correct it quick. So here, it shows that the size of my vec keep growing. After adding 5 elements, my vec size was 5. After adding the first number 13 was size 1. But then also we say you enter the following numbers, And the numbers that was at this address, because this was integer, they're integer and this compiler is 4 bytes long. So the first one was D0 at memory address D0, the next one is D4, 4 bytes contiguous memory location. Vector is like array, and they are taking contiguous memory location. And then D0, the next 4 elements D4, and the next 4 elements D8, DC, and E0. So it just adds up 4 elements. And then for the memory, my VIC sub 0, and the first element was 13. So array start with 0. This was the first one, and the last one is 4. There are 5 elements. So if you want to print the last one, in this case, because it was array size of 5 elements, this one is 0, this 1, 2, 3, 4. So the last one is also my VEC sub 4 because there were 5 elements here. And then elements value is also produced here. Now we're saying the elements were pushed on top of the stack, last in first. Now we show the elements in the LIFO order, last in first out. So now we're going in reverse order because of those for statement that we say go from the end -1 to down to 0. Either we subtracted from the for statement or we increased it. So this was as a result of printing it in LIFO, last in first out, because this one was last in, 15 was last in, the first one to pop. 3 was last before that one, and the second one to pop. 4 was before that one, and then the third one to pop, and so on. And then 13 was the first one, so we pop it last. Now there's nothing on the stack. We popped everything from there, if we look at it that way. And then we also say that in addition to this, if I pop the last 2 elements of this one, so because we always pop from last in first out, now our array is in reverse order, 15 and 3 is the last 2. And then I said, okay, the last 2 is 4 and 3 elements. So here element number is 4 and 3, and 15 and 3. Notice that the memory address of these ones are the same as memory address that were in here. Because once you store my VEC1 sub 4, that is an array pointer. My VEC1 is a variable that is to a memory address. It's almost like a pointer. A pointer always has an address, and that address is pointing to a variable that is holding the address of a variable. In this case, my VEC1. The address of that variable was E0, and then if you look at it on 4, it's E0 here. If you look at it on 4, it's E0. So that one is consistent across. Let's just fix this part here to have a space, and then run it with another value, a different number of values. So I'm going to do vi myvec1.c++, and then the area we wanted to modify it was saying that the size of. So here, when I say my vec size is equal, right here I needed a space there, and then I could just put one space or a tab. So let's just put a space here. We could do that. And the space is, if it is 1 character, even on the cout, you rather put it as a single quote, because I'm just putting 1 character space there. But if I'm putting it like multiple character space, then I could just do it. And sometimes it's much easier to just say, much more readable to say tab it rather than 1 space next to it. So now tab it is going to just do that. So since I modified the program, I'm going to just say G++ minus O, my vec1.c, my vec1, and then my vec1.c++. I compile it again, make sure that there's no typo. Now my vec1 is going to be run, and this time we're going to get some new input. Can you please provide me some input again? Anybody? I read the first one. Hello?
23.
23, thank you. Next,
14.
14.
77.
77. Let's do two more. This time
55.
we just 55 and what else?
84.
84. Okay. And let's just add a big number also, like 1 million. That's 6 digit. So we do with -5 this time. So now we just saw that the way we inserted the record, and then we compile it and run it right here. We say myVec1 and myVec1, and then it says enter the value. So these were the value that were inserted. Again, this time because we had 7 elements, and myVec.size can just be 7. So I could have just also put a tab here on the last one. Actually, this one did not get, after adding this, did not get updated. Let me look into that one, why I see that there's no tab here. Could be because of the set W, maybe we have to check it. You enter the following numbers, and then this time everything is added 0 to 5, 23, and then the last element, which was element number 7 on indice is 6, because the start with 0 is 1 million. So now we show the elements in the life order is the opposite, and then if we look at the last Vec, because we pulled the last 2 elements. The last 2 elements in this case was from the top of the stack, was 84 and 1 million. And that's how we did it. And notice the memory address, again, the same thing, but because it's integer, they are incremented by 4 bytes, which means a contiguous area of memory location. So let's just correct that part, and let me read after adding. After adding, and then we have after adding the number, and then we need tabs. Okay, so we put the tab somewhere where it didn't belong. I think after adding right here the number, we need it right here. The tab should have been right here. Because whatever you see the input is saying after adding this, my size, yeah, my size is good, that we need to tab it there as well. So after adding the tab, now it's good. And then let's just compile it again and run it again. This time we are going to try some number 5 minus, not minus, let's say 55, 20, and that's good enough. So we just go minus 1. And then notice this one, it says after adding, there's a space, myVec, and then space. This one, because it was 2-digit, it moved it a little bit to the right side. But if we use iomanep and want to format it, you can configure that one, because on this statement, when I did the cout, I did not use the set W, and therefore it did not format it. Here on these memory addresses paste, I used the set W, and then here I did the same thing. So that's why the format looks cleaner. Here, the format is a little bit out of places. Some of them are tab, some of them are this. Tab is not gonna help you, because tab is determining the size of these numbers. If the size is 2-digit, they all go in the order that it is there. And for this one, it holds 2-digit. Once it's 3-digit, it moves this one to this. Now tab it from this one to here, it moves it. So it's better to use like some kind of set W on a manipulator, and depending on the size of this string, you could say set W 20 or 30. So that characters will be printed like this. And then 20 characters from there, it will read it. And then if characters are small like this, it still moves it, shifted to the right, and then 20 characters or 10 characters from there, spaces for you. And then you have the set fill if you want to change the space to some characters, some dots or something. You have those options, as well as converting it to uppercase, lowercase. There's a lot of IO member functions, and that we did cover some of them, but I believe and that is going to be covered in details in your future classes. So that is good. Now, let me just go back to this other window. And this other window, this time I'm going to resize this window and then hope and that the second program is not too big for the output. We can, if we have to, we come back to this one. So vim MyVec2.c++. This program I'm doing it is, let me resize this one also. That is better. And so we, to read some integer values from the standard input console or terminals, that's all the same thing, standard input console terminal. These all programs that we are doing it is from the console, and so we're reading it. And then display it back and display the content of the vector in reverse order. In this case, we're not doing much other than the first program, but I'm gonna go to the way that I did this one, a little bit different than other ones in terms of, yes, we're still reading the input from the console in, and so we're displaying the values after displaying it. Here, number, MyVec, and I need to do another tab here because the other program I didn't do tab either. Here, the number, I did a tab here. And then the CN is very, very important. Say, please don't forget this. Forget to this to make sure the while terminates. So if you are not providing the within the while statement, so here we read the CN number, whatever that number is, and that's always greater than 0. If you don't read another CN number, this is going to go to an infinite loop. As long as that person does not give a negative number, it could read those numbers. So make sure that you don't miss this one because it's going to go to an infinite loop. The second thing that's important is that your output statement, like when you do line numbers, maybe break it into subsection. Do one section first to see what you're doing here. You're reading data here. Then use this for statement to print it out. And in this case, we're printing out MyVec from size. MyVec1.size has the number of elements that we read into the vector. And then here, when I'm doing printing it, I'm printing the ampersand to print the address of it, as well as the actual kind of content of what I'm printing. So I'm putting MyVec1 and then left parentheses, then close the quote, then put I, because I want to print I, but I want to put this in this string before that and this string after. So it says that something like this, except the value will be printed for it. Say MyVec1 sub 1, sub 0, sub 2, and so on. And then that output will print it, display it. But this one, we're using something that you haven't done in the class yet, because this is later chapters in advanced class that you take, called vector iteration. Iteration is nothing but just have a fixed memory location that is like a buffer in memory that you always are using the same buffer, disregard to which iteration of how many thousands of numbers you do. The iterator is on both C and C++ was introduced to make sure that you could just increase the performance. It's very, very efficient in terms of performance. When you're working with vectors of millions of objects and millions of data that are maybe not of the same type of integer or a primitive data type of a string or character, but it's a class or a struct. Those kind of objects, you need to have some sort of iterator to just go through millions and millions of data. Sometimes when you are working with data science, for data science, whether you use Python or C++ or shell programming or Bash or awkward programming, anything, a lot of these things when it comes to big data is just the way you write your algorithm and how you optimize your code. And even when you compile it, you have the dash uppercase O for optimization to make sure that your code is sufficient. So iterator is one of those kind of looping data structures or looping kind of, it's called iterator itself. It iterates through from beginning to end of something or from a section of something. And that iterator in this case is also defined within the for statement as a vector. The reason we did it iterator as a vector because we're working with vector here. So if you're working like here, we're doing unsigned integer, we're using unsigned integer here also. So we could have done it this way and then just use my vec sub I or use a IT for iterator, and then for iterator from end to beginning, as long as it's IT is equal my vec1.end, which means at end of it -1. So the pointer is pointing to the last element in this case, and then this one is the first element, beginning -1. So beginning -1, you have to do it because you don't want to lose the last element. In this case, minus because we start from the end. And we want to go towards the beginning, so minus IT. But notice that the IT is, we're using it as a dereferencing that value as a pointer, star IT, because it's a memory location. In order to print out the value of that memory location of iterator, we do asterisk in front of it. So then this one is also showing the address of it. The reason I'm showing this one to show you the difference in memory location from previous programs versus this one when we are doing iterator, and iterators have a fixed memory location. It is a buffer that holds the data, and that's why in the iterator is faster. So in this case, I'm going to do a G++ -O, my vec2, and then the program is my vec2.c++. So this one I did not have any error. That's why echo $? is successful 0, meaning that it did create my vec2, the executable. Notice the executable has a different color than the first source file because the color Linux marks it as green. There's an alias like ls. If you can see the ls, when you do a ls command, by default, and the Linux has ls color auto, meaning that whatever the color of executable file is, then it's going to mark it as executable. And this one is a source file, and the permissions are different. And notice one trick that I show you, which is inaccurate in terms of Linux marking this. So Linux doesn't care that this file is by type my vec2. If it is a source code, Linux is going to look at this one and say, oh, it's a text file. So therefore, I'm going to have the permission of read, write, and -r. And how it is done, for example, let me just do attach a file. And in Linux, you can say attach my, let's say I'm going to call it my vec6.c++, which is an empty file. I haven't done anything with it. So if I do ls -ld, my vec 6.c++. And notice that this file, my vec6, is also showing C++ source code is empty file. I have not done anything, so it says, well, this one is a 0 byte, so I'm marking it as 0, even though I have the extension C++. But if I put a line in here and I say echo pound include IO stream, and then send this output to this file with double greater sign, I'm going to write the content of this echo statement to my file, my vec6. Now my vec6 has about this many bytes of characters. So maybe 15 or 17, but how I do know it, if I do a less minus LD, you can see that the size is basically 20. So however, that number of characters is there. That one, if you count this number, pound this all the way together, maybe it is exactly 20. But this time, if I do a file on it, notice that it says, oh, this is a C source code. It just read the IO stream and it did not understand that this was a C++, even though I gave the extension of it as C++. But maybe I could add another line of this one, say, just Victor, because Victor is not on C. So I concatenate by adding this one into this file here, my vec. So now I just do the same thing with LD, and then the size is 38 bytes. Now I will go say file type of it, it still says C. Let's just do something here, and VI my, and you can see that my vec.c++, it did not have, it had a couple of lines that was related to C++, but the Linux compiler did not understand those ones as type of C++, and it says that it is not. So now I'm going to just add one more line, using namespace std. Let's see if I just do this one and look at the content of it, what it is. And then now it just says C++ because of the using namespace. So certain keywords on that type, it just knows what it is. But another problem is that if you just look at it, this is not finding it. So my ls minus ld, my vec6.c++. And notice the color is this. And UMask, I mean, the permissions is read, write, read, write. So the reason the permission is showing read, write, read, and dash write is because of the UMask. In Unix, when your UMask, this last 3 digit is 002 on the UMask, this one tells it that every time I create a file, if I create a file, the number 666 minus 002 will be just the permissions of the file, which means it's going to be 664. And 644 is equivalent to read, write, dash, read, write, dash, and read, dash, dash. How do I convert that one? Because a 7 is read, write, execute is 7. A 6 is, this is 7. 6 is read, dash, write, dash. This is equal 6. And 4, 5 is read, dash, x is a 5. And this is a 5. And read, dash, dash is a 4. So let's just give you the definition of these numbers. So if I just Control C out of it, I have that one on the screen. So I'm going to say And the way we calculate here, these numbers, the way and this read write dash is, and the first three, if it is read write dash, that means is a 6. A 6 is calculated like this, 2 to the power of 4, okay, 2 to the power of, let's say power of, I'm just going to do power of 2 because you are familiar with that. 2 to the power of 2 is equal 4 plus power of 2 to the power of 1, power of 1, and that one is equal 2. So 4 plus 2 is 6, plus power of 2 to the power of 0. 2 to the power of 0 is equal 1, right? 2 to the power of 0 is 1, this. So when we have all the bit set, like the one that I said, it is this, read, write, execute, meaning that this one is on, this one is on, and this one is on. So 4 plus 2 plus 1 is going to give you 7. If only this one and this one is on, meaning that 2 to the power of 4 is on and 2 to the power of 2 is on. So that one is 4 plus 2 is 6. If only and this one is on, let's say the execute bit, the 1, so that means dash dash x, only the 2 power of 0 is on. That's how the UMass conversion is happening. But if it is a file, this is a file condition. If it's a directory, I say make dir new dir, and then ls minus ld new dir. The permission of this one, notice that it is 775. So for the directory, Linux and Unix does a 77 minus 002, the mask, the UMask. So the output of that one is 775, and that's this is on all read, write, execute. The other one is read, write, execute, and the other one is read dash x. That's how it's calculated for this. So every time I create a directory, it's going to be having permission of 775 in this case, because the UMask is that. So rm dir new dir, and I'll make dir d1, and then ls minus ld1 is there. See, the same kind of permission. Rm dir and d1, touch a new file. The file is always read write dash r, because it is 664, and that's the same way. It's because of this UMask. I hope that is clear to you. And if you have question further, I'll explain. But let me show you the part that I wanted to show you with the other file, rm dir new file. So rm, if it is a file, you don't do rm dir. It's just a file. It's not a directory. So rm would take care of it. And then now we are looking at a program called MyVec2.c++. And then again, if I look at both of them, one of them is in green color and the other one is there. So if I just look at the type of them, file star, file this, you can see one of them is showing executable, the other one. But Linux is not smart enough, or Unix is not smart enough when they does the alias with auto color. It is not smart enough to say, if I change the permission of this file is a source code. Even though the type of this file is going to say myvec2.c++, but the color is going to be misleading. Let me show you what I mean. So change mode, I'm going to just do 755 to make it executable for read write for myself and executable for everybody. myvec2.c++, and now myvec2.c++ is already in color. just because the permission of executable bit is set. So if I just want to do even like 700, only for myself, read, write, execute, and nobody else have access to this file to read or execute or something, that is here is the permission. But notice, because I have for the owner is executable, now I can just still see it in color. When I do a file my vec2.c++, you can see it's at the source text file. So when you see this color, you don't just say, oh, my vec2.c++. It's not going to run the code. It's not a executable, right? So at this time, I'm going to change the permission, change mode to 664, my vec2.c++. Now we're back to my vec2 the way it was there originally, because the permission is there. And if I do a file on type of it, it's the same thing. Okay, so let's just run this my vec2 now. My vec, I'm gonna clear the screen because there's a lot of garbage there. My vec2 dot executable. Enter a list of positive number. Because of the screen, I'm gonna only put a few numbers. Okay, let's do 55 here minus 1. So notice that I put these numbers. It says after adding 5, my vec1 size is 1. After the second, the size is 2, and after the third, the size is 3. You provided the following numbers. And notice, because it's my vec1 is an array of contiguous area memory. My vec is a vector of 3 integers. In this case, it just takes 3 integers, 0, 4, and 8. I mean, 0, 4, and 8 is the address of those ones. Everything else is the same. The address just increment by 4 bytes, which integer in this compiler is 4 bytes. Displaying the vector from end to beginning, as from the bottom to the top. And because we use iterator, notice the iterator has a fixed memory location, 408, 408, 408. It did not change. So if you have millions of records, it's just the same iterator. And it is a buffer of memory that's allocated just to do manipulation of that many elements in an iterator. And that's why it is fixed. It is that fast because it is just going through like a list kind of architecture. Since I say the list on this one, let me just jump into Python for a few seconds or a couple of minutes. I'm going to just jump into Python 3.8 here, and then I just show you some example of a list that I can increment it and really huge. So I could say my list is equal, and I'm going to say let's use the variable x for x in range of 1 million numbers. So that's 3-digit, 4-digit, 5-digit, and 6-digit. I believe that's, yeah, 6-digit. So I go on this, and then if I don't give any numbers, and this array gets created on the fly very fast, my list is just giving all those numbers. Look how big it is just to store all these elements for 1 million numbers. And the system is gonna just display them, and before it reaches to 1 million, we will be just spending so much time. So I'm going to Control C out of it. And while this one is running, I could Control C, and then finally, in the buffer, sometimes Control C even doesn't break it out. So I could do the same list. This time I'm going to do it only with 10 numbers, just to show. Now my list is those 10. If I do it with a bigger number, 100, and then my list, look at on the fly, I can do this. And if I just am interested in on this, let's say f x mod for modules 2 is equal 0, then I'm only getting the positive numbers in this case. Now you just see all the positive number. If I needed to say not equal 0, that is all odd numbers. And so you can guess how much easier it is to generate a list and then manipulate it and do some work on it. While this is just a small example of Python, I said I'll cover just in a minute or two, but same thing, we're doing it with arrays. And then later on my VEC, I'm going to show you, for example, here, look, if I do a dir of my list, these are all the member functions and then the member function and the methods that are available for me in order to manipulate on this my list, which is a list type. So if I look at the type of my list, I can do this. It's a list class, which means that I can sort this one in reverse order, like I say my list dot sort, and it will just sort it. But now my list already has the sort there in that order. But if I say my list dot reverse, so I could reverse it, and then now this is also in the iteration, so it already reversed it. Now I run my list there. You can see that, sorry, my list of reverse, let me just, it's not in place. So I think I have to do my list on reverse and then, yeah. So I did not use it as a function. The method is in place, but you have to do it as a function like this. Now the reverse order is happening there. So there's a lot of it, like the pop is similar to pushback. So if I just say dot pop, this one is going to pop the first element of it there, because the my list dot reverse is just put it in that order. The last element is what I'm popping here. And now if I do another pop, is 3 is going to pop, another one is 5 is going to pop, and so on. And then I could do a statement like this. I could say for item in my list, and then I could say my list, I could say print my list dot pop. So if I do that pop, every time I print that one, notice that it, whatever was left on the list, it popped it. And then in addition, like for example, for my list, let's say my list here is in the sort reverse order, doesn't matter. I can just say add more elements to the list, increase it, decrease it, resize it. And I will show you on the C++ as well on this, because I tell you on the interpreter of Python, you can play much faster than and just write a bigger program in an IDE and then compile it. But on the interpreter, because each line that you write it gets interpreted at one time, and versus a compiler is faster. It just compiles the entire page of source code into object files and executables, and then you run it. That's why it is based on the processor. Did you run it, and it was already compiled for that processor. It is much faster. But this one, in order to play around and just look at some of the functionality of the data structure as a training or teaching the environment with Python, you can see it in a shorter amount of time, more examples. So let's just do my list let's say I'm going to do from 0 to 10. And then I want to just get only those lists here, the first 10 elements. And then if I want to just copy it to another list, I could say list 2 is equal, and then now list 2 is just having those ones. I just on the fly did this one. And I could also say list 3 is equal my list 2 dot copy. I could also do this, the copy function, to just, actually, it's not allowing it that way. Let's see if I could do list3 dot copy. I'm gonna say list3 dot copy list2. Okay, dir of list2. If the function list2, oh, I'm typing something wrong. The name L3, L2. Dir of L2 is there. So if the copy is here, that means I should be able to copy it. So I was typing something wrong. No, I was typing L2, but let me see. L2, oh, my list2, I did not have my list2. So L3 is equal L2 dot copy. That would, L3 would just get this one. But now notice that L3 is made as an object. I need to do copy with a function. L3 now has the actual elements there. So I could copy it, I could do it, I could count some elements. If the element number is there 2 times or 3 times, I can get an index of it. I can reverse it, I can remove it, the contents, I can insert more elements, or I can extend it. All these functions are there. Let's just use the extend function, for example. L3.extend, and if I just want to extend it only with one element, I could say 5. And I'm going to have to put this one with this, but then this one as a list. So now L3 just got added here as an element. But if I wanted just an array of list of 5 again and 55 and 10, now I have L3 grown with these numbers extended. And notice the difference here. Even though I put it as an array, it extended to the same list. It is not made as list of list. Right? So it created a list of one additional element. It appended to the end of it. Let me see if I could just say, use the insert here. Then the insert takes 2 arguments. It says expected 2 argument, you provided 1. So where you want to insert? If I want to insert it in the first element of element sub 0, then I do that one with 0. And now I say L3. Notice that I inserted as another array inside this bigger array. So this is array of arrays. So when I say L3 sub 0, it's going to just show me 5, 15, and 10. And if I just say 1, it's going to show me 99. And then 2 would be 97. And minus 1 would be the last one, that element number 10. So you could just print everything by doing colon here, or just say start from 0 to everything. And then these orders were writing for statement and everything, but notice how simple it is in Python. I'm going to exit out of here, so we continue with the second example. And now I'm going to clear my screen. I'm going to run my Vic to again the output, and I provide some number. And so now notice that I did not give a negative number here. It is still expecting me to read some more numbers. And then once I put a negative number, it's going to say, oh yeah, you finished now. 55 was the last one within the for statement. And then that's why there were 5 elements altogether, 0 to, 6 elements, 0 through 5. And then the reverse order displayed it in back order is that these numbers. Do you have any questions so far? Okay, let me just open up another session here, another terminal. I'm going to show you my Vec sub 3. Let me just resize this window. So vi myvec3.c++. And this one, set a number. I'm going to demonstrate a number of things on this one. So I'm going to read the description to remind myself what I wanted to show you. This program reads some integer values from the console and stops reading when it sees the first negative number. It stores the data into a vector, myvec1, and then it displays the numbers entered as well as copies the same numbers as a second vector, myvec2. So the Python script that I showed you to copy one vector, the other one, and now we're on C++, copying the contents of myvec1 to myvec2 and display it in reverse order. As we copy it, and then later on, we also display it in reverse order. We're also using the IO manip for displaying the contents in a nicer format. And then the vector indices and the value of each memory location is stored in the vector. We want to display the vector indices as well as the memory location. So this part is similar to myvec1 and myvec2. We're reading numbers, and then we're pushing it into the myvec1 with pushback method, last in, first out again. And then we're reading the cn inside the while statement, so we don't have an infinite loop. And then let me just move this one a little bit to the right, and this one a little bit to the right. Is still too big for this screen, and my vec is, I could just, I know that the word is assumed here. So I'm going to move that one and then move this one also here, and then save it. Okay. So in this case, you provide the following. We're printing out with setw with IO manipulator. Every time I'm printing these ones, as I print out memory address, I give a space, so the string starts here and ends here. If it is shorter than 20 characters, then it puts the spaces around it. If it is exactly 20 characters, it's going to occupy 20. And the same thing with this, and then it prints that one. And then we need also a memory value for myvec1. So let me just add one more here, and then we say element values. So because I put the this, I get rid of this semicolon, and then this one I don't do new line, and this one doesn't have a new line, this one doesn't have a new line, and the last one has a new line, so now we have it, and we're printing these three values for each one of those two. I mean, those three. We're printing those ones in a nice format, and then we give two end of line. We could give one end of line, that's fine. At the end, we want to give two end of line so our program doesn't mess up with the other programs. And then here, copy the vector myvec1 in reverse order. And unsign myvec, push back. We're putting it in reverse order, so we start off with I being myvec1.size, the last one, and then decrement it until we reach I greater than 0. Once it's the last element, we stop. And then because we say greater than 0, that means we have to do myvec I minus 1. And instead of this one, size minus 1 and I minus 1, you better do this one inside here. This way you get the last one and the first element. Otherwise, you miss one of them. If you just do a minus 1 here or minus 1 here, you may get out of Stack Overflow or something. So try to do it this syntax. And then inline memory address here, we're printing the same thing here, but the second example here, since we did a copy, every time we use the vector 1 from top to the of the stack to the bottom of the stack, we push it into the new vector called myvec2. And myvec2 is the same data structure that myvec1 is. integer of type, so as a vector. Then we push it, and then it stores the same number of elements to it. And then as we push it, we just print out myVec2 later to compare it with myVec1 to see if we copied it correctly. So let me just compile it, g++ minus o myVec3 dot myVec3 dot C++. So the same source code file is there. It is read from the .c++ file. The object file is attached with the compiler loaders, and then the myVec3 file gets created as executable link format, and then the source file is there too. So at this time, I'm going to clear my ls minus ld myVec3. Notice when it creates the executable, the permissions are also by the G++ is set based on this umask that I told you. Every time a file gets touched for executable, this is the permission for it. And for source code that are just a text file, this is the permission for it. Again, the permission is based on the 775. So umask minus umask is 775, meaning that 77 minus 2 would be 775. So here I'm going to clear the screen now. I'm going to run my Vec3. Can you please provide me some number here, this one? Go ahead, please. Gabe, I thought you were talking. I saw things were moving. Okay, somebody wrote in chat. Let me see. 47, thank you. And Gabe wrote 47, so I'm going to put 47. And let's just give some more number to save some time. 30, and then 10, and then -1. So at this time, I entered 4 numbers, and that's why 5 numbers, 4 numbers. 4 numbers, and then the things were there. And again, the tab is not there, so it is just printing this. And then this time you can see the memory location is contiguous integer. It moved up 4 bytes every time we print it, get it second number. And then the copy of the vector elements, it was done exactly the same way. But since we printed in reverse order, the last one is going to print first, the next one from last is second, and so on. So 10, 30, 47 in the order of from the bottom up on the top of the stack, last and first out. So let's just correct this one typo here. On this one, we just add vi my vec3.c++, and where we printed out here on this statement where we say adding number. We could even don't have to put the anchor. We could say tab here. That would automatically put tab after that one. And then just get rid of this space or just leave a space. That's also going to work. And then this other one does not have a tab. So I'm going to put a tab here because we already have the code here. So I'm going to compile it, say, just go to the compilation again and compile it, no errors, echo $? And then run myVec, clear the screen, and run the myVec again. And we provide number 47, 50, 10, 12, 11, just a few more numbers. And then -1. And then you can see that once I put the -1, it stops reading. So 11 was the last number, and it printed out in the reverse order. But notice this one adding this is there, 47, but then my vec.size does not have it. I'm gonna correct it one more time. My vec.size, right here, the tab did not work on it. It should have printed my vec.size.
I think you're just missing a space in front of my vec.
My vec.size?
Yes, right in front of that's the left of where the cursor currently is.
You mean I'm missing a space right here? Because when we do tab, it should take care of it. Oh, right here. You're right.
Yes.
Right here. Yeah, right here. I want to put a tab. This other one has a space here already, so it is okay. But my vec.size after the number did not have it. So either you put a space like Gipsit or tab. I wanted to tab it since I did the other one. But let's just take Gip advice. I rather like that one better, because when the string is put there, you just want only one space here. But this value, you want it tabbed, that's fine. Here also, if you want to tab it here, we could do that. So it's okay. Either way, it should work now. So we compile it and then clear the screen and we run it. We give some numbers, 10, 55, 50, 100, 2, minus 1. And then you can see that values are there. The 100, because it was bigger, it was there. Moved it, as I said earlier, with the format of manipulators. I did not use setW on those ones, but the bottom ones I used, and then it's nicer, cleaner format. But the important thing is that my vec1 was copied into my vec2, and my vec2 was printed out in reverse order. Reverse order meaning that whatever was on top of the stack is printed first. 2 is printed because the order that we entered 10, 50, 100, 2, 10 was inserted first as element number 0, and 2 was entered as last element. And when we pick up the last element, it is that order, reverse order. Okay, so let me show you. It's 8:19. I'm going to show you another program on this screen. Let me just switch the screen for this one. I'm going to go with the green color. Actually, we did the green color already. So let's just do the blue color. We haven't done the blue color. I like blue color also. So we size this screen here, and let's just open it, vi myvec4.c++. This is a larger program, I believe, compared to all the other ones, because I'm doing a number of things on this one. If you look at the last line number of this one, it is about 98 lines of code, which is not a big, and it's not a small either. So we demonstrate a number of things as on the vector, what you can do. I did not show you the resizing or maybe finding an element and deleting it, but I'm doing a lot of other ones that as time allows. And obviously, when you take your second course, you're going to practice a lot of these. So at this time, I'm doing a number of vector dynamic data structure, last in, first out, we call it. Show the examples of how to create a vector, how to initialize it. Like in this case, on line 24, we create a vector of type integer. We call it myvec as the name, but we instantiate it with 4 different values. We could grow it as long as we want, but we can just add on later. If you just put a semicolon after this, like in the previous one, we can just push back. If this semicolon was right after my vec1, then we could store new values. The first one we push back into it, it would be my vec1 sub 0, and the second one would be my vec1 sub 1. In this case, my vec1 sub 0 returns 5, my vec1 sub 1 will return 26, and my vec1 sub 3 will return another number 4. But notice that, and then 2 is obviously return 55. I just wanted to jump into 3 because I thought that you already understood the rest of them. So here, when we are doing this, my vec is similar to array. The vector is exactly what we did operation of array, except the vector has different member functions and different way of manipulation. And also vector can grow dynamically and shrink dynamically. So you can resize an array or a list when you define it of type vector. But array or double array or two-dimensional array, you cannot resize them. That's the limitation of the array. But vector is kind of like dynamic. You can grow it and you can shrink it. And there's a function called resize. You can just add to it, or you could just push back like this, and automatically the vector dot size gets updated as you push elements into it. And as you pop, the vector size changes. So in this case, if I want to print my vector dot size, it has only 4. But once I put this pushback of 3, 30 and 35 and 50, then it has 4 more elements. And then as I pop, it's just reverse. And then the size just dynamically could go. And there's a function resize, as I mentioned. There's also a function like myVec.erase to erase element, myVec.insert to insert elements, and so on. A lot of this one, myVector.clear to clear the entire vector. I'm showing you some of those examples here. So here, after inserting 4 new values, we want to print the vector. And again, the for statement uses unsigned integer because we're putting only positive numbers, with I being 0 to the max vector size. That's not a negative number, so we better define it unsigned integer, and then it's much faster in terms of the for statement running faster. This one, I'm going to update the value of my vec sub 4. My vec sub 4 is the 5th element. My vec sub 6 and sub 5 is the 6th element. But then I want to change it like array. We were defining it. You just say array sub 4 is equal to this value. Now we just are saying my vector sub 4 or vector sub 5, whatever it is. You just want to change the value. Look how simple it is. Just like an assignment statement, you assign this value to this. Now you updated the 4th and 5th element. And then after updating the 4th and 5th element, I want to print it. So line 47 through 51, or just doing that. And then line 53, after inserting new element at 5th index. So at the 5th index, I want to just only insert 1 element. If I only insert 1 element, that means I have to have a position that I start with, which is my vec1.begin. This .begin or vec sub 0 is just pointing to the first element. But when I add 4 to it, it says move 4 elements from that one. Even though 0 plus 4 is funny, 0 plus 4 is 4, but it's actually in the computer because vectors start with the first element as 0. Now we're looking at element number 5 because every time we're talking about indices, if it's we're looking at 4, we're pointing to the 5th element. If we're looking at 10, we're pointing to the 11 because the first element was 0. So when we count the number, we start with 1. And when we, in the computer for statement uses indices, it starts with 0. And that's how computer science works. So in this case, and this is true about all programming languages that I know of, whether C, C++, Java, Lisp, Ada, Pascal, you can name it. Any programming languages, Python, anything. It's all the for statement or the while statement. When it's using an array of indices, it always starts with 0 as the first element. You can always, start with 1 if you want to, but that means that you have to see where it meets your needs. That's what I'm saying. So here, after removing first three elements, after first three elements, and this time I'm reading the first three elements and erasing the first three elements. But the erase method had a way to just delete one element. When you do one element, you go from the begin to the position of that element, and then delete the number that you wanted. I mean, insert it in this case. Delete is similar. Delete, erase, if you're just erasing one element, you just provide the position of that one. But if you're deleting more than one element, you have a start position and then an end position. In this case, I'm deleting three elements. So my first element that I start with is begin of the vector, and then three elements from the beginning up. So that would be begin plus 3. So that is the first element, and then the three elements from that point will all be deleted. And then my vec1 here is just compared. In this case, I'm also checking for the vector. If I deleted those elements and did my vector become empty, so you can just use the function myvec1.empty. If my vec1 has a value of .empty has a value of 0, that means it's not empty. If it's a value of 1, it's empty. So I just define a vector status as a string on the top. Obviously, I include a string library, and then the string library allow me to declare a string name with the vector status. And later on, when I do check on the status of my vec, rather than give the status as 0 and 1 and tell somebody that 1 means true and 0 means false, I just put some kind of customized script, a string name saying that if it is 0, my vec1.empty colon false. And otherwise, my vec1.empty is equal to. As a programmer, you just sometimes look outside of the box and make it cleaner for your readers and users to make sure that they can see some number without any interpretation from there. And was 0 true or was it false? 0 means false in programming languages and computer terminologies the majority of the time that I know of. And then if you just want to define it differently, you can. It's your code. So my vec1.empty is false and my vec1.empty is true, and otherwise, if it is value is equal 1. Since there are only two values, I did only put else. I did not put if else is equal 1, then put it value this. For unsigned an integer, here we're doing the same thing. The status of my vec1. And then it will print those values. And then after finding a value of 4, so this time I'm looking for 4. For 4, if it is found in my list, then I remove it. So I just forcefully, I went in my list, and then right here, when I initialized, I deleted the number 4. And originally I had it on the position 26, but because in my program I deleted the first 3 elements, I just had to reorder this one and put number 4 in the other order, because it's not like that kind of situation, but I knew in the code that I'm deleting the first 3 elements. So if it was in the first 3 elements, this find command would not find the 4th and any order. It was already deleted by your program in the first place. So, and sometimes it's just a little bit check and balance kind of condition. So here I look for my vec sub I. If it is equal 4, and then I erase that my vec sub I. Whatever is at that position begin plus 1. If it found it on the position 5th, then it would be begin plus 5th, which would be 0 plus 5th, and the 6th element has the value of 4, and it will be deleted. And then after clearing the entire vector here, I do a clear the entire vector, and then at this time, all my vec1 data structure or vector data structure is clean. It's just erased. By clear command, by clear method, this one I just get rid of all the elements from it. And then I just check the status of it, and I should get a value of empty is equal true. The first element, because it was not true, it was not empty, I just had that situation. So I'm going to compile it again, my my vec4, and then my vec4.c++. So let's just run this one, and then do a echo $ question marks successful 0, and then file my vec4 star, and then one of them is executable, the other one is source code ls-ld, my vec4 star, and it's you can see that it's executable bit set. So I'm going to clear the screen and say my vec4 there. But because this time we were just doing, let's just see if I can do a pipe more. Yeah, if you do a pipe more on this screen, you could still see on the top of the screen and there. Since I just inserted initially these values 5, 26, 55, they're printed here. The current content of my vec1 is that. And then after inserting 4 more elements of this one, which was 30, 25, 35, and 50, and 100, now the vector size grow from 0 to 8 elements, right? So the next thing that I'm doing here after updating 2 of existing one, notice that element number 4, which was 30, it changed to 200. And then element number 5, which was 35, it changed it to 5 5s. So it updated everything else, those numbers are there. This was a sort of those assignment statement that we did, those 2 values got changed. The next thing that we did after inserting new 5th index is equal my 5th. So now on the index my vec sub 4, let's see, my vec sub 4, we added this 111. So that was an insert of that one. And then after removing the first 3 elements, the first 3 elements were these 3. So after removing these, now we left off with these, which are these numbers, 4 to 100. And then now status of my vec.empty is equal false because we still have these elements in it. They're not false. And then after finding a value 4, value 4 was found on array my sub 0 this time because we removed the first 3. Since it found it, it removed it. It removed it, and now we end up with the rest of these. And right here. This time, I'm clearing the entire my vec, and then even if we printed it, vector is empty, this doesn't print anything. So my vec.empty becomes true. And that's the end of your program. And I'm gonna just open one more window here, and let's see which one we should do. I believe we didn't do this one. Yeah, we did that one. And let's see the first one. Yeah, this one we're going to do my vec sub 5, the 5th one. My vec 5.c++, and you can see that this is a source of this with this many lines. So let's do a vim or vi my vec 5.c++, and this one set the line number, and this one is the description says to display the content of my vec1 with an ordered list of values, and then add some elements to it. Display and update vector v1, insert an element my vec1 and indices of my vec2, remove the last element of the vector. This time, instead of removing begin to the 3rd, we are just deleting the last element. Check if the vector is empty or not, clear the entire vector, which we also did it on the example 4. this part. So IO stream, vector, string, those ones are the one that we include, and using namespace is good. On this one, I initialize my vec1 like before, and the values are these. As you can see, there's no 4 on this one because I'm not deleting it. So I have different values here. My vector status, again, is a string because I want to just see if it is true or false, when it is empty or not. And then here, I'm just printing the current values of the vector. And then after I printed, then I push these values to the vector, which we did in the last example. Then we print it out. Print it out, and then after updating the last 2 elements, again, 4 then 5 is updated. We can just change the number to do some other ones, doesn't matter. And that's just a number. And then after inserting a new element 5 to my vec sub at location 4, this is indice 4, which is the 5th element. And then here, notice that I'm saying insert by my vec sub 1 dot begin plus 4. So this is the position where I'm putting it at the 5th element by finding the beginning of the vector, adding 4, the number 4, so I could go to the element number 5 and then put the value of 555, and that's how insert works in this case, because I'm inserting 1 element. And then for this one, when we are doing the array, we are printing it, and then after removing the last element. In this case, look at the arrays is simple. And you just say my vec1 dot n minus 1. You just erase the last element. N minus 1 would be just pointing to the last element. And then my vec1, we're checking if it's empty. We give the status. If it's not, we give a status. And then print afterward the loop. If the was empty, this would print nothing. If it is not empty, it would print something. And we did not put these for statement inside the else part or inside the if statement, because I did not assume that my code, whatever, I'm clearing it already here, so it must be on the else part that it's empty. I did not want to do that one. I just wanted dynamically to work at all time. Don't just, if somebody moved this clear command somewhere else, then this one doesn't have the else part correctly. So you have to put this for statement outside of it. And then the rest of them is just comments. So I'm going to compile it G++ minus O. This time I'm going to just say my vec5 dot C++ minus O my vec. So the order doesn't matter. When you say that dash O, then it says what is the output file name. If you just give the source code before, it just knows that, and this is the source code that I'm using. My vec 5 star, and you can see that they're there the same, my vec 5 star, and it's there. And then if I just clear the screen and run my vec 5, notice this one I'm going to also do a pipe more because I want to see the top of it. So these were the elements, and then we added these other ones to it, and then updated some of the values to these. So 25, 30, and 35, changed it to 200 and the 5 fives. And then after inserting a new element in the 5 and the 5th position. So 5th position was 200. Fifth position was 5th elements, which is the 6th indice is number 6. Where was it? Yeah, 5. What did I change? Of my vec sub 4 at 4 and become 5, and then after removing the last element. After removing the last element, in this case, the 100 was removed, so we got 50 through that. Okay, and then Now my vec.empty is false because we still have elements here. But after clearing the entire vector, my vec1, now the status is becoming true. So the if statement followed by that. And clear the screen, ls minus ld star my vec star dot C++. So these are the programs that I'm going to post on the module and there for you. And outputs are shown already on the video. If you want, I could also put the outputs, but I rather you practice them at your time or at the lab times, and then my vec star. And these other ones that are executables, I'm not gonna just provide the output on the modules and you just run it again and give different values and look at it and find out other things with it. This is all available and will be available there. That one, my vec6.c++, I'm going to remove it. And that one is just extra that we created for